Okay, so guys, let's keep going and trying to learn these essential concepts a little bit better. So here's a problem that I gotta make sure you understand. Notice we have two different variables. We don't know what they're about, but we know one averages 38 with a standard deviation of 12. The other one averages 35 with a standard deviation of 9. And we're trying to compare them. We're told they're independent, means they're separate samples. One's not affecting the other. What is the standard deviation of the random variable x minus y? So the idea is, let's say we're trying to compare them. Normally we would take, for example, 38 minus 35, and this would tell me that the mean difference between x and y is 3. If one averages 38 and the other averages 35, what's the average difference going to end up being? 3, right? Now, what about the standard deviations? We must remember, whenever we combine two separate sample deviations, standard deviations, guys, they always combine with Pythagorean theorem. So basically, I'm going to take the 12, I'm going to square it. I'm going to add it to the 9, squaring it. And then we're going to square root it, right? That's Pythagorean theorem. So here it is on the calculator. I squared each one. By the way, technically now these are variances, because that's all variance is, guys, is just the square of our standard deviation. Okay? And I get 225 for their sum, and then I just need to take the square root of that 225. I know together they will have a standard deviation of 15. And so that's why the correct answer would be D. All right. 27. Guys, notice they give us a lot of information here, but the key thing is, which of the following is the best interpretation of slope? You guys should know that slope. You guys should know that y hat always has a form of a plus bx, right? Where a is our y-intercept. In a computer table, that would be the constant value. And b, of course, is our slope. So all we are focused on, guys, is the 0.4 here. So if you look at A, notice they're talking about 16 miles per hour. That they're talking about the y-intercept. Who cares? We want to know about the slope, right? B talks about variation using the correlation here. Again, that's true, but that's not what we're talking about. C, for each additional 1 foot in height, the top speed increases by 0.4. Now they're finally referring to this slope 0.4, right? Well, that looks like a good answer, doesn't it? Let's look at D. For each additional 0.4 feet in height, now remember, guys, if we get more specific, our speed, I'm just rewriting this here, equals 16 plus 0.4 times the height, right? Our variable, our x variable is the height, which determines or helps determine the speed, right? Well, it's height that we're going to change, or it's the control variable, it's what we're varying. And the speed results from the change in the height, right? Not the other way around. So D is wrong because they're trying to get you to flip the slope around, right? No, it's the height that we're going to adjust or change, and that's going to result in our corresponding change in speed. Okay? But anyways, they're trying to confuse you with the slope there. All right? Let's look at choice E. For each additional 1 foot in height, the top speed increases by 0.4 miles per hour on average. Ooh. So guys, look at this. C almost tricked me. Because remember, guys, when we're doing this analysis, everything is going to be averaging, right? So that's the key word that makes E the better choice. So C is a good answer, But the more accurate choice is, I know every time I increase the height here, guys, by 1 foot, the speed is going to increase by 0.4 on average. So that's why the correct answer is E. Almost got tricked. So you guys got to be careful. So notice, guys, C was a good answer. E was a better answer. Okay. Finally, we have 28 here. Guys, you guys should know this A here is what we call uniform. See how, or close to uniform. See how it's basically almost constant straight across? Its mean and median should be, therefore, about the same. On B here, guys, notice how this one's skewed to the right. You guys should realize that somewhere near the peak here is my median, but because I'm averaging in these higher values, my mean is going to shift to the right or to a higher value. So whenever it's skewed right, you should understand the mean will generally be higher than the median. The median will be closer to the peak still, okay? Let's go to D here. Notice how this one's nice and symmetric. So the mean and median should be very close to the same as well. Notice E, even though they inverted it like so, do you agree the average in the middle is still going to be right there close to each other? Long story short, guys, please understand that whenever it's skewed left, the median is going to still be close to the peak. The median literally is the middle value. Notice most of the numbers are going to be at the peak, and therefore the median or middle number will be close to the peak. And therefore the mean, because I'm averaging in these lower values, is going to drag that mean down lower than the median. So if you read it carefully, we want to know the one where the mean is less than the median. That will be C, because when you average in those lower values, the mean is going to get lower than where it should be, okay? And so the mean will be lower than the median. So that's basically it for these three questions, guys. Please, again, make sure you understand these three inside and out. By the way, guys, I want to remind you that when I start doing Khan Academy again, you will get to practice 26 and 27 for sure again. See, by doing Khan Academy, you do learn real AP stat stuff, and I want to make sure you understand. I'm not sure if 28 is going to come up in Khan Academy at all, but I will tell you, the bottom line, guys, is we got to study and make sure we do Khan Academy seriously in a legit, correct way. Don't just run through, look at the explanations. Okay, let me memorize the answer and then plug it in the second go around. Okay, guys, obviously you're not learning that way. So let's do Khan Academy right. So when I'll be more selective, but when I do Khan Academy, guys, know that it's focusing on something that you need to know. All right? So I'll see you in class.